And welcome back to Piece of Physics. Last video of kinematics, we just covered speed. Speed is a scalar quantity. What if object moves in particular direction with some speed? In that case, speed with the direction is known as velocity, right? Consider one graph in which we have y and x-axis, right? If particle is initially at some position here, okay, then this particular vector r1, this particular vector is known as r2. Okay, if particle moves from this point to this, right? So this is the path on which distance will be dependent on. Okay, but the shortest path between initial and final position, the shortest path between initial and final position is known as displacement. Displacement is known as delta r equals to r2 minus r. Okay, so this is the displacement. Okay, now what is velocity? Velocity is known as vector v, which equals to delta r by delta t. Okay, this is a vector quantity. It is meter per second or kilometer per hour. The velocity can be 0 meter per second or kilometer per hour, right? So these are the basic description about the velocity. Okay, now let us move to the average velocity. So basically the back brackets, okay, this equals to be the total displacement upon total time, right? This is equals to delta r by delta t, where delta r is the total displacement and divided by delta t, it will give us the average velocity. Okay, and what is instantaneous velocity? Velocity at some particular moment is known as instantaneous velocity. Okay, so I can write instantaneous velocity as v equals to limit delta to 0. This is delta r upon delta t. Okay, this is equals to dr dt. Okay, so basically instantaneous velocity is known as dr upon dt, and it equals to v. Okay, so we have to just differentiate the position vector. It will give us the velocity. Okay, now let us solve some questions based on the average velocity and instantaneous velocity. So we can have how to deal with the velocity problems. The tip of the minute hand between 6 a.m. to 6:30 a.m. Okay, so radius of the minute hand is 4 centimeter. This is 10 to the power minus 2 meter. Okay, and also we have to find average 6 a.m. to 6:30 a.m. Okay, now as you know, this is the clock. 6 a.m. minute hand will be here and 6:30 a.m. minute hand will be here. Okay, so total displacement is equal to the diameter. So delta r plus r delta t equal to 30 minute. This is half r. Okay. Now what will be average velocity? Average velocity will be equal to delta r by delta t. Okay, delta r is twice of r divided by delta t is 1 by 2 or 1 by 2 r. I can write it in second as 1800. Okay. So twice radius is 4 centimeter, which is 4 into 10 to the power minus 2 divided by 300. Okay, by solving it you can get the answer. Similarly, from 6 a.m. to 6:30 p.m. in the case of B, displacement again will be twice of radius, but time will be equal to 12 and 30 minutes. Okay, in that case you have to find the answer based on the data. Okay, so this is your DIY problem. Okay, you can do it yourself. Now let us move to the next question. The next question is, a person traveling on a straight line moves with a uniform velocity v1 for some time and with uniform velocity v2 for the next equal time. The average velocity is v is given by, okay. Now we know that average velocity is basically total distance, like d1 plus d2. These are displacement divided by d1 plus d2. Okay. Here to here and here. Okay. So here suppose displacement is d1 and displacement is d2 here. Okay. Velocity is v1. I can write it as d1 by t, and v2 here is d2 by t. Right. So d1 will be basically v1t, d2 will be equal to 2t. So this will be v1t plus v2t divided by 2t. Velocity vector will be plus v2 by. So our correct answer for this particular question is option A. Right.